Welcome back. Today, we're talking about independence through time or independence from past events. This topic comes up when we're dealing with a probabilistic event that happens more than once. And humans really love to make inferences about such events. So I want to illustrate what can happen here. Now, I'm going to deal with a very simple coin flip because it is essentially the simplest probabilistic situation, but the same argument applies to all kinds of situations. So I'm using a $50 here because it's larger and more visible on the video, but it's just a standard coin. Of course, the coin is fair. I'm going to flip the coin, and let's just say, for the sake of argument, that if it's heads, I win, and if it's tails, I lose. So let's flip the coin, and we'll record the answer. And I got tails, so I lose. I'm going to record that here. Okay. Let's flip the coin one more time. And I got heads, so I win. Okay, good for me. Again, I got heads again. Okay, that's pretty good. I'm feeling good about this. I've won twice in a row. I'm feeling good. And I got heads again. So again with the heads. Okay, so I'm on a roll. I'm on a streak. I've had 3 heads in a row. Now, this is an ordinary coin, and I don't think that you will infer here that I have demonstrated any particular skill in coin flipping. You might suspect that I've cheated. I could have cheated, but I didn't. I've won 3 out of 4 of these contests. So this is not because I have any particular skill. This is not because I'm applying any particular method. This is probably just because dumb luck. I got lucky, right? So I won 3 out of 4. 3 out of 4. So what are we to make of this? Well, no big deal, right? I mean, this isn't really strong evidence that the coin is unfair or anything. What we can do with this is I want to ask you a very important question. I'm going to flip the coin one more time. And now, when I flip the coin one more time, I want you to think about what has happened in the past. And the past has been kind of imbalanced, kind of unfair. What does that indicate about your expectations about what will happen next when I flip the coin again? Do you expect that you will get heads, that I will get heads, or do you expect that I will get tails? Now, from your point of view, it's done already, but from my point of view, it hasn't happened yet. So what do you expect will happen? Let's make 2 arguments before we actually flip this coin. One argument that we might make here is that there is this law of large numbers that says if I flip the coin a very large number of times, approximately half of the coin flips should be tails, and approximately half of the coin flips should be heads. And so I should expect, after many, many flips, that there would be some sort of balancing here. And this balancing can't happen unless I eventually get more tails. And so that might indicate to you that we should expect the next flip would be tails. There is another argument there, and that is that we've got heads. We've got heads. We've got heads. I'm on a roll. Right? The coin is hot. I seem to be doing well. This is my lucky day. I'm winning. It's good. And so I might expect that what should happen next is, well, I'm more likely to get heads and less likely to get tails because I am on a roll. That's what it means to be on a roll, right? It means we're doing something and that thing will tend to continue. So I want you to hold these 2 arguments in your head, and I want you to think about which one of these arguments is most likely to be correct. Is it more correct to say that because of the law of large numbers, we expect eventual balance, and expecting eventual balance means that we should be more likely to see tails? Or is it more correct to say I am on a roll, the coin is hot, the coin is generating heads, and therefore it's more likely that I'll get heads on the next flip? Now, again, from my point of view, it hasn't happened yet. So I can do this one more time, and maybe I'll record it in another color because it feels somewhat special, because it feels like I'm testing these 2 hypotheses. Let's write down the hypotheses before we test them. So hypothesis 1 is because of the law of large numbers, which predicts some sort of long-term balancing effect between how many heads I should get and how many tails I should get. So tails are more likely. And hypothesis 2 is something like because I'm on a roll, we should expect heads more likely. Which of these hypotheses seems more likely to you? Well, I don't know. I'm going to flip the coin, and I have to get heads or tails. So let's see what happens. So I got tails. Does that mean that the first hypothesis was correct? Maybe, maybe not. So you see this kind of thinking, we see both of these kinds of thinking very commonly. We do this in sports, we do this with games that we play. Um, Humans are incredibly good pattern detectors. We detect patterns without even knowing it. It can cause us problems sometimes. So one of the ways in which we detect patterns is in our relationships. If you have a conversation with somebody 3 days in a row and seem to go badly each one of those days, we detect that pattern. Even maybe if we don't know that we detect that pattern, we detect that pattern and then we react to it, we respond to it, we overgeneralize sometimes. If something seems to be going our way, then depending on your personality, you might be optimistic about that and say, well, it's just going to continue to go my way. Or you might tend to be pessimistic and you say, well, I'm due, right? I'm due for something bad to happen, right? The thing is, in the natural world, things are rarely completely random, right? When we're dealing with people, our relationships with people are not completely random, right? They're based on the personalities involved. When we're dealing with sports, which feels kind of random-ish because we calculate a lot of statistics and it can go either way, but it's not really random because it's also involving the skill, of course, of the players, right? It's not just random whether you score or not. It involves your skill and your skill in relationship to your opponent. So in most natural circumstances in life, there really isn't complete randomness. And for that reason, we love to make patterns and we love to take those patterns and those pattern forming habits and extrapolate them to situations which are completely random. Now, this is a fair coin, and the results here are completely random. And so I think the point of this lecture is that both of these ways of thinking are completely wrong. And the correct hypothesis here, which we can call hypothesis 3, is so it's a coin, and the probability is 0.5. If the probability is 0.5, then it can't be more likely heads and it can't be more likely tails. You can't hold those two ideas in your head simultaneously. You can't say it's 50-50 and simultaneously say it's going to be more likely to be tails, or it's time for it to be heads, or it's time for it to be tails, right? Those are incompatible ideas. The truth is it's a coin and the probability is 0.5, and I have to flip it, and one way or another, I'm going to get heads or tails. But what the key message here is the past has no bearing on the future. Now, this is not true for non-random events. For non-random events, the past is your best information about what's going to happen in the future, right? If you're dealing with your relationship, the past is the best information you have to predict what's going to happen next. If you're dealing with a sporting event, the only information you have is what's happened in the past and how do you use that to predict the future. So in almost all cases, when we're actually dealing with people and their interactions or the scientific world, the past is our best information about the future. But with a truly random and repeated event, the past has no bearing whatsoever. And the fact that I flipped the coin 4 times in order to generate some sort of historical position here had no bearing whatsoever on what would happen next. One thing had to happen, but it wasn't affected by these things. And there is no long-term justice here. Like, there is no restorative effect. It tends to be about 50-50. That's a long-term thing. But if it has not been 50-50, then it doesn't tend to restore back to that equal thing. It just tends to generate 50-50 results into the future. So this is the most important lesson I want you to take from this. With truly random events, the past and the future are truly independent, and therefore the past gives you no information whatsoever about the future. Now, there are various fallacies and errors of thinking that people tend to take on. One of them is called the gambler's fallacy. The gambler's fallacy is a fallacy that causes people to gamble and causes them to lose more. The gambler's fallacy is I have lost, and I have lost, and I have lost, and I have lost, and therefore it's time for me to win. The other gambler's fallacy is I have won, and I have won, and therefore I'm hot, and I will tend to win. Both of these fallacies are kind of a form of denial, a denial of the expectation that I will eventually lose if I gamble. And believe me, casinos and other gambling opportunities are designed so that you will lose long term. Otherwise, they would not make their money. So gambling institutions design these experiences, which will cause gamblers to lose in the long term. But our own brains work against us. Our own brains will tend to rationalize and get us into these fallacies where if you've lost, it causes you to expect winning, and if you've won, it causes you to expect winning. At least if you're the kind of person who has that kind of attitude. So that's the gambler's fallacy. You see this in sports too. A lot of the time, events in a sporting event are so evenly matched that this person will win a point, and person A will win a point, and then person B will win a point. Person A will win a point. Person B will win a point. And we have all of these very clever commentators who can tell us what happened and why, who can tell us about their strategic offense and their strategic defense. But a lot of the contribution to the outcome of a sporting event is just truly random noise. And I'm sorry to everyone who ever plays sports, including me. It doesn't feel good to know that a lot of the outcomes here are actually just the results of a whole bunch of random noise. But stuff happens in sports, and it's largely outside of the direct control of the players. There's a lot of just dumb luck and random noise that affects whether this shot hits or misses, whether that attempt succeeds or fails, whether they catch or miss that throw. So a lot of that stuff is actually random noise. And for that reason, a lot of the kind of momentum that people seem to perceive in sports is actually just illusion. It's actually just the result of random noise. Now, not all of it, because sometimes you really do have a good day. And so people are more complicated than just random noise. And so sometimes you really do have a good day. But some of it is just so much random noise, and it doesn't really give you any true information about what to expect in the future. So the law of large numbers, the law of large numbers used to anticipate the next of a truly random series of events is a mistake. It's a cognitive mistake. If you have a truly random series of events, the best thing you need, the only thing you need is the probability of the next one, and the previous don't matter. The idea of being hot, or it's my lucky day, or these kinds of things used to anticipate continuing a prior trend in a situation of random events is an equal cognitive mistake. So the future is independent of the past in truly random processes. Don't make those mistakes. The probability is the only guide that we really have with repeated random events that can tell us something about what to expect next.